Let's see longest palindroming substring problem from the LeetCode. It's a medium level problem. So let's try to understand this. Before that, let's see like what are the companies, they have this question have been asked. So yeah, so this question has been asked in many companies like Amazon, Bloomberg, Google, Uber, and you can see the list. Yeah, let's try to understand this. So as per this problem, there is a string given and we need to find out what is the maximum length of a string, that is palindrome. So if you see like any character, any single character, that's itself is a palindrome. So but if you see ABA, this is a palindrome. And if you see the BAB, that's also palindrome. Yeah, we know the palindrome, like if you see the last one, the first one, that's the same. If you reverse that, that's the same. So that's the palindrome. So we need to find out what is the maximum length of that palindrome in this in this substring. So this should be the substring. So the BAB is answer. ABA is also a valid answer. So if there are like more than one palindrome substring and they're same length, you can return anyone. So how to do that? So one of the way is we need to find out all the substring. We can find all the substring, all the possible substring, and then check each string is a palindrome or not. So like if you try here, like put the I here, and then from the G we can put the J here, and and then J start with this. We can take B, next time BA, BB, BA, BD, and next time again. So you can check this, you can form all these substring, then you can start with A, and then AB, AA, AD. So you can find, or AB, AD. So you can find all these possible substring, and then you can try finding the palindrome. So in that way, this solution itself is big O of n square. So that's the n square, and then like getting all these substring, all the possible substring is n square, and then again you check whether that string is palindrome or not, that is n. So total is a time complexity is nq. So that's not the good solution. So there may be other solution for n square and n also, but today we'll see n square solution. For the n solution there is a different algorithm, so we'll see that sometime in the future, but today we'll see n square. But for the n square, how to do that? So let's take this example here, and we'll go to the another screen and we'll try to understand, and then we'll write the code here. So for this string, we can consider this as a x-axis, and consider this as x-axis, and this x-axis take like each number, and we can say that's the center number. So that's the x as a center number, and from there we need to search left and the right. So for the example, like let's say just for understanding, in a loop we traverse this, like, or we could just say go to each character, and from here let's say we are at B. So B itself is a palindrome, and then now we'll move the orbit. So orbit will move one left and one right, and we'll check that okay, this orbit. So in this orbit, just consider this is a circle. We just move one left, one right, so that's a circle. So in this circle we'll see okay, left is also same, right is also same, so this is the palindrome. And if you find that's the palindrome, then move that orbit again, one left and one right. So again we'll come here, and then from here we'll check that okay, this is again palindrome or not. No, this is not a palindrome. So in that case we'll stop there, and we can start for another character, like let's start from here, and then move the orbit one left side, one right side, and for the VAD we'll check, and that's not a palindrome, so we'll stop. So this is something called, for the odd numbers, like if you see the ABA, that's odd. So for the 3, 5, those kind of thing. So we need to expand, this we need to expand this orbit for even also. So for the even number, if you try, maybe you can say, okay, we can put something like between here after this, or something after A, or something after this. Like if you check this port, then we can put something here. So yeah, so when we iterate, like we cannot exactly put here, but we can consider this way, and we move the pointer like one back here, so, and we'll consider this 4, and in that we'll expand our orbit there itself. So we'll see how we'll do. So first I'll take this example for the event. So like let's say 0, 1, 2, so our x coordinate is at 2. So yeah, so there is a lot of the loop here, so I think this logic need to be clear, so that we can go and write the logic. Let's we put the x is 2, and then we check something like, and for this I can say orbit is 1, and the length is also 1. So length I need to find out, exactly I need to extract this thing. So for that I have to put the length. So let's do a little bit math here. So now x is 2, and we'll check like x minus orbit. So if I do the x minus orbit, that is 1, x minus 1, so I will go here, and I will check x plus 1, then I will go here. So in this case that's the same, and if it is same, so I can check like if x minus 1 equal to x plus 1. So I'm just giving the value, but we are checking the character on that position. If it is same, the character like let's say like this here, and if the character in this orbit it's the same, in that case we can move the orbit, like not a move, like we can increment the orbit plus 1. So if we do the plus 1, then orbit will be 2, and the so when we expand, then we move the orbit by 1. I mean not a move, but we expand or increment the orbit by 1, but the length always incremented by 2. So in this case orbit is 2, and for the length, if I increment by 2, then length will be 3. And from here now orbit is this place till here. Okay, so in this case we'll check, okay, this time in the D and this B, it doesn't match, and if B and D doesn't match, so in that case we have to stop and we have to extract this thing. So we need to find out this substring, that is the palindrome. So for that, in order to find that, we need to let's say we need to calculate the begin and end, so that we can extract this substring. So for the begin, I can say this is x, so x is, we'll start with x, so x is 2, so I can say the x minus the x is 2 here, so it was here, and then x, so x is 2, so first put the formula x, and then minus L divided by 2. So if I do the 2 minus L by 2, that is L is 3, and 3 divided by 2 1, and that's a 0. So the begin is 0, so we can begin L x is 2 and 2, this is a 1. Yeah, so the begin is 1, so we can start from here, and we need to reach here. So that is the begin, and the end we need to calculate, and for the end we can start with this begin plus L. So if I do the begin plus L, so the begin is 1, and that's L is 3. So if I do this, then it's a 4, and then 0 1 2 3. there is something like 0 1 2 3 4. Yes, so 4. So if I say start with here and the till here, so if I say the 4, it will this, when you do the substring, this character won't be considered. So anyway, we'll get this ABA. So this formula we are going to use in our code. So this is for this odd number expansions, and for the even number expansions we'll do this similar things, but we'll start from here. Then in that case we need to add +1 in our condition. So we'll see in the logic about the even things. So let's write the code for that based on this math. So I'm here, and then we can just iterate for, I can say x is equal to 0, x-axis, so an x less than length of s, and then x plus plus. So we'll iterate through each character, and then I can say orbit is 1, and then length is 1, and we can check here for, we can also we need to check the conditions, like when we expand the orbit, it should not go outside of the boundary. So I can check if x minus orbit greater than equal to 0, it should not go in the outside of boundary, so it should be greater than 0, and x plus orbit, so x plus orbit is less than length of a string. So that is the condition we need to put here. So in this example, not this one. So yeah, in this example, like when we expand here and minus and then plus this side, then we need to check this should be within the range, and that's also within the range that is greater than 0. So that's the logic we are setting here. Now we can check if s x minus orbit is equal to s x plus orbit, and if the both character is same, then we can increment orbit, or we can say orbit is equal to 1, or we increment orbit by 1, and then length increment it by 2. Okay, and we, before the for, let's create a variable. It's a var result, and this is a string, and the end we are returning, we're going to return this result. Okay, so we are expanding, and else just come out of from the loop. So we are expanding, we are checking, the left side, from the center left and the right character is same. If it is same, increment this orbit by 1 and length by 2, and if it doesn't match, then come out of the this loop, and then again come out of this inner loop, and we are still in outer loop where we move to the next character, and then again we use the same formula over there. Okay, so come out of this whole complete loop here, so this inner loop, and inside this we can check if this length is greater than length of result. So there is something in a result. In the first time there is nothing, but if the L is greater than length result, so in that case we have to put the formula. So if L is, then we need to find out the begin. So the begin is x minus length by 2. So that is the begin, and so that's the formula we put, and end is equal to begin plus L. So, and then we can subtract that string, that is from s begin to end, and we can put that in a result. So that's for the odd number of expansion, and for the even number expansion you just copy everything here, and we need to, first thing is, like, we need to check this length of 1. So that means, what does this mean? So when we iterate this this value, then we have to make sure we are till here, because that is we are expanding, and then we cannot go beyond this. So that's why we need to keep till here. So that's we can do here. So now, so for that I added this logic, and here we need to do +1, because we are for the, this is for the even the orbit expansion. So we can put +1 here and +1 here, and this logic is good. Orbit plus L, that's still good, and in this place also we can put +1, and that's all. So let's run this and check for any syntax error. So it's an orbit. Okay, so I need to define this a new variable, so then I have to put the colon this place, and again here, and this place here. Let's run once again. Begin. Okay, this is also new variable, so put this begin end, and we copied the same thing, so begin and end come here. It's wrong answer. Why? Let's check. CB output is BBD and expectation is baby. So that's the formula we put. X2 x minus 1 2, yeah, so L by 2 my x minus L by 2. So I think that looks good. Let's check once again. So here let me check. So x minus orbit, that's greater than equal to 0, and x plus orbit less than length is. So that's oh, okay, no, I think this is equal, then increment orbit and length, increment this length by 2, then length greater than result, then only we need to calculate this begin end, and we can start as begin and end. So that's also good. X0 length -1 orbit 1. Oh, okay, so one thing you need to start with this L, you need to start with 0 for this even number. So that was the one mistake. Let's run now. Okay, accepted. Submit this. Great. So now that's fine, and this is just a loop and this increment few things. So I think logic is not very much complex, so it can easily be written in a Java language. So that's why I'm not writing this again in Java language. So that's all for now. Thank you.